It is an anti-addition, which means if the one X is above side. Hello everyone, today we are going to discuss regarding the addition of halogen on alkene. So as you are aware that we are discussing the preparation of alkene halide in the whole series through alkene. So in this part we have already covered up the preparation of alkyl halide through Markovnikov rule, through anti-Markovnikov rule, and today we are going to discuss regarding in these two reactions we have taken the reagent as HX, and today's class we are going to discuss the addition of X2, how the alkene react with this X2 and we are getting the alkyl halide. Our main purpose is to prepare this alkyl halide because we are studying regarding the alkyl halide preparation. So today we will discuss how with the help of this alkene we can prepare this. So what will happen over here in the HX part when we were adding this, so at one carbon the hydrogen was coming and the other carbon we were having this halogen, but in this case both the atom are X only. So what will happen over here, at both the side we are going to get halogen only. On this type of halogen, this type of addition is known as vicinal dihalide. In this type of reaction we are going to get the vicinal dihalide. The formation of vicinal dihalide is going to be formed over there with the help of this X2 with this alkene. And generally we take a reagent that is termed as CCl4. This thing we are taking and the reaction is being proceeded. So how this mechanism, and one more quite important thing, this product is anti-addition. It is an anti-addition, which means if the one X is above side, the another X will be the below side. Why is this happening? Why we are having one X upside and another X below side? Why all this thing is happening? That we are going to see in today's class. So for this we need to get into the depth of this, which means the mechanism. This is our alkene, CS2 double bond CS2. When it reacts with X2, you can take over here. So what is happening over here? Although they are some induced dipole is being induced dipole, due to which one X will be a partially positive and another will be partially negative. On that partially induced dipole, this halogen, this X is going to attack. What we are going to get? CS2 single bond CH2 single bond X. This X is neutralized and we are getting a 1X negative over here. This leaves out. So what will happen over here? A generation of positive charge. So to remove this positive charge, what it will do? This is going to attack at this carbon and we will get a product like this, CS2 single bond CS2 and Br positive, like this. A three-membered ring is being formed over here, and this three-membered ring, what is going to happen now? Because it is not that much stable, a positive charge on bromine. So what will happen? This X negative, we have taken X, so generally we take bromine on the reaction, that's why, yeah. So now we have taken X, so this X will be over here and the another X moiety will attack over here and it can attack at this carbon. Both the possibilities are there. So then what will happen over here? It will attack over here and we will get a product like this. CH2 single bond CS2. If this attack from upside, it will moves down over here. Anti-addition. The other possibility is that if this attack from upside, this is going to be leaving from this side or like this. If that attack from the X from upside, so this will be like CS2 single bond X. So this is the way. The overall thing over here is that the anti-addition, both the halogen should be anti to each other. The mechanism is following in that way that both these are anti to each other. So you need to know the key point of this reaction is that they are added to 1,2 position, or you can say vicinal dihalide. And another key point over here is anti-addition. Another key point is anti-addition. In the same way, we can take part for Br2 and Cl2, etc. So this was for this reaction of addition of alkene with this halogen Cl2, Br2, I2, etc. Now we will see some few important type of reaction, such as if this is a reagent, which means the allylic position we are having an allylic compound. If we are having an allylic compound and this allylic compound when react with this Cl2 or Br2 at a higher temperature, at what level? At a higher temperature, nearly 773 Kelvin. The temperature is quite high, nearly 773 temperature. Generally, sometimes you will see that this type, or sometimes you will see written as like this HT, which means a higher temperature is being used. So what you are going to see, so now this ClBr will not attach at this point, but they are going to attach at this point, the allylic position. They are going to attach at allylic position. If we are getting like X2, so the product will be CH2 single bond CH double bond CS2 and X over here. So addition at allylic position. Addition of this halogen at allylic position. So this is like the formation of alkyl halide. Formation of alkyl halide through the allylic compound. One more reagent we can take in place of this. We can also use NBS. Then also we will get a similar type of product. This is nothing but N-bromosuccinamide. But the main difference over here will be, this will give us CH2 single bond CH double bond CS2 Br, because only Br is there, not the whole X. N-bromosuccinamide. This is our N-bromosuccinamide. So if you see over here, this N-bromosuccinamide attacks over here this bromine. Okay. This bromine is being taken from here with the help of this, proceed to the free radical, this Br free radical, and it attach at this carbon. Why at this carbon? I will tell you that thing also, why these are following this carbon, because if you see over here, CH2 free radical single bond CH2, this is the most stable. And if other possibility, if you see CH2 single bond CH single bond CH2. So here we are getting a double bond at this position free radical. They are not stable. So that's why the most stable free radical, with the help of that, this mechanism is being followed with the free radical. So we are not going to the depth of this mechanism, but just I am telling you, it follows the free radical mechanism. That's why it is attacking at this allylic carbon over here. So this was for allylic compound like NBS and Cl2Br2, and one more is that SO2Cl2. If you are having SO2Cl2, if you are having SO2Cl2, then also you will be attacked at allylic position. If with the help of this SO2Cl2 also, we are going to get a product in which we are having allylic position is being attacked by this halogen. See, SO2Cl2 means ClO is going to attack. If you are given with some Br2I2, then we can see some other possibilities. So just one or two reactions are remaining. I will discuss that also in this. The one reaction which I am going to discuss is this RBr. This is halogen. When it reacts with HGF, when it reacts with HGF, what we are going to get over here? RF plus HG Br. Sorry. Silver. Ag. HGF and AgBr. This type of reagent we are going to get. This is a transmetallation type of reaction. This type of reaction we can see, and this reaction is known as Schwarz reaction. This reaction is termed as Schwarz reaction. And another type of reaction, just to form, because these RF are not generally alkyl fluoride are not being generally formed by the other ways which I have told you in the previous lecture. So this is the way how we can synthesize this alkyl fluoride. Now for alkyl iodide, we will see if we are having RBr plus NaI, RBr plus NaI, RBr plus NaI will give Ri plus NaBr, sodium bromide. So, and this reaction is known as Finkelstein reaction. Finkelstein reaction. Finkelstein reaction. So these are the two name reaction which I have discussed in the today's lecture, and the rest about this allylic carbon position, how this addition is taking place at allylic carbon, and rest all you can see. Now if a quick revision you need, so we can say we have discussed addition of halogen on alkene to prepare this alkyl halide. We have seen over here that this was the previous class. We have discussed the addition. Now we get anti-product, vicinal product. This is the whole mechanism, how it is following. 3-membered ring, less stable, attack of this X negative, and we are getting a anti-product which is a vicinal product. And for allylic, I have shown you the 3 possibilities are being discussed over here. One with SO2Cl2, one with a high temperature, another with the NBS. All of them are going to give us allylic position substitution. And due to this NBS, I have shown you that most stable carbocation formation is this one, allylic position. After that, we have discussed 2 name reaction, Schwarz reaction and Finkelstein reaction, in which the transmetallation takes place generally. You can say that transmetallation takes place. This RBr NaI, the main thing over here is acetone. This reaction generally takes place in the presence of acetone. So this was from this class. In the next lecture, we are going to discuss how we can prepare these alkyl halide from alcohol. and after that we will discuss the aryl halide preparation. That's all for today. Thank you.